This is a tutorial for the Solidworks test. Consists of 2 parts that you have to make, as well as an assembly that you have to put together. There's a total of 5 parts. You get 3 of them for the assembly. And then, of course, the 2 you gotta make, like I just said. Okay, so let's get started. First off, we're gonna do this pretty simple one. This is a rod. There is a dimension missing from this. It's the actual thickness. Right here, this line, that's going to be 15 millimeters, but everything else is defined. So let's go ahead and get started. First of all, we're going to want to make sure we pick a metric template, or if you're having trouble, if you don't have that template set up at the bottom, you can always go to the bottom right-hand corner and change this to millimeter gram second. Alrighty. So starting off, I'm going to create this profile right here. So we have 2 holes that are at 5 millimeters each. The radius at the bottom is going to be 5, and the radius at the top for the outer portion is going to be 7.5. I'm going to be using circles to draw that, so keep in mind I'm going to change this. I'm going to just multiply this by 2 to get a 15 diameter, so this bottom to get a 10 millimeter diameter. Okay, so let's get started. So I'm going to start off with the front plane, and I'm going to do a circle here, and do a construction line that goes straight down. And I'm going to do another circle here. I'm going to make both of these circles equal by highlighting both of them and clicking equal on the left-hand side. I'm going to define this as 5 millimeters. It's really important that you make sure that this actual line has a vertical, it's constrained vertically. So make sure it has that symbol. Otherwise, you can pull this left and right. So now that this is defined, we need to define the length. That's going to be 100. And I'll just bring this down really quickly for you to see. If you look, you can see that there's 100 millimeters between the holes. That's where I got that from. Cool. Now I'm going to go ahead and do a circle here. Oops. And a circle here. I got this from here earlier. This is going to be 15 millimeters. And this bottom one is going to be 5 millimeters. And oh, sorry, not 5. It's going to be 10. And remember, like, if you're having a hard time, it'd be good to, if you're watching this, if you have just the picture next to you to look at it while we're getting after it. Okay, let's keep going. So I'm going to go ahead and do a line here, and I'm putting this like incorrectly, almost on purpose. It's just really important to make sure that these don't have vertical constraints on them because they are slightly angled inwards. They taper down. But the reason I put this right here is because I don't want to accidentally assign it like a horizontal relation with this center point. Sometimes that happens. You just have to delete it and requires more work. But now that I have that done, I'm just going to grab those 2. I'm going to make that tangent. I'm going to grab these 2. I'm going to make them tangent. Another little trick, if you go from left to right, it'll select anything that's within that box. But if you go right to left, you actually have to select the whole part. So if you, or sorry, the sketch component or whatever it may be. But yeah, so right to left, it'll select anything. It'll come up the green box. Left to right, it's going to be this, you won't select unless you have the entire sketch or component, whatever it is within that box. Okay. Same thing with the bottom here. I'm gonna move this a little down so I can do this. Nope. Don't want that. Boom. Tangent. Just click. Tangent. Cool. So I'm just gonna go, you don't have to trim this, but I just like to because it only takes a second. Trim, trim, trim. Oh, trim, trim. Cool. I'm going to extrude this 15 millimeters. This is the missing dimension on that drawing I talked about earlier, but it's 15 millimeters. I'm going to do this from the mid plane. If you're wondering how I'm actually doing, like, I'm not reaching up and grabbing my sketch icons at the top, that's because I have this wheel. So if I start another sketch on the front plane, I have this wheel. My top is this smart dimension, top right, 3-point arc, center circle, corner rectangle, center rectangle, midpoint, normal line, and construction line. That's my setup personally, but you can tailor that to however you like to do things. So we'll keep going. Get out of here. Okay. So I started another sketch on this front plane, and this is so that way I can focus on this geometry that's in the center. So if we look at this geometry, I want to start on basically a plane that it follows my cursor, and I want to extrude that, or do an extruded cut from the mid plane to get rid of that material. And you can see here, if you look at this, it actually shows us the profile and how that center portion is sketched out. Okay, so. Yep, we're on the front plane. So what I'm going to do is I'm going to go ahead and convert entities. 1, 2, 3. Convert that. I'm going to do a center point arc. You'll notice that I didn't actually use my wheel for that one just because the center point arc isn't something that I have on there. Center point arc. That's going to be our center. I'm going to click on here. Now you'll notice that this arc is going in the wrong way. So that's not how I want it to be. I'm going to get rid of that. And then I'm going to let's do that again. If that happens to you, if you have it the wrong way. Okay, so now it's going the right way. But let's go like this. Okay, so now it's like this. If you have this problem, what you're going to do is just go all the way back around. I mean, kind of just keep doing it until it works. But this is kind of surprising because it's not working. Oh, wait, did I get it? There we go. Okay, cool. Boom. Easy money. All right, so we got that center point arc. It's just really important that this is our center right here around this circle. We're going to go ahead and define that as 50. And you can see that called out. Shoot, where did my thingy go? Boom, boom, boom. Here we go. Yeah, so it's really important that's around that center point. That's going to be 50 millimeters for that radius. Cool. Now I'm going to go ahead and just trim that off the top, do an extruded cut. It's going to be 15 millimeters from the midplane. So we'll go and do this drop down midplane. Sorry, 15 millimeters. It's going to be 5 millimeters. It's my bad. And we're almost done with this guy. So what we're going to do is we're going to go and chamfer. Now the call out for this guy is just basically 1 millimeter chamfers at 45 degrees pretty much everywhere. There's not an edge here that isn't chamfered. So we'll go ahead and do that right now. And this is really easy. Let's make sure that we have 1 millimeter. Full preview on the left-hand side just makes things nice and easy to look at unless your computer's dying or something. But just gonna start selecting faces. You get a chamfer, you get a chamfer, you get a chamfer. Everybody gets a chamfer. I select the wrong thing. I accidentally selected an edge when I meant to select a face. There we go. That is this part done nice and beautifully. Very, very simple. Okay, fantastic. Now let's go on to the next part. So again, we want to make sure that we have a template, our communism template in millimeters. So I'm going to start off with the front plane. Now, let's go ahead and look at this guy really quickly. So it's definitely more complicated than the first one. Just looking at this, you can immediately tell if you have experience in SolidWorks, you want to use a revolve on this guy. It has some of the things that is interesting is all of these guys are equal lengths. It has some complex geometry, kind of like this dip, like on the inside that revolves all the way around. So let's go ahead and start tackling that. And I'm not going to pull this up as much. It'd be more beneficial if you just had the picture on the side to look at it. Okay, let's get this started. Okay, so what I'm going to do right now is I'm just going to draw an outline of the part. And once I have this outline done, I will go ahead and just define it all. But just getting the simple outline done first is nice just to get it out of the way. Okay, so this outline ain't perfect. It never will be. So let's go ahead and start defining. So looking at this guy, this top portion is completely flat. Looking at and keep in mind we're only making half of this part because it gets revolved. So looking at this, we can see at the very bottom, this is 10 millimeters from dip to dip. So you can tell that this, if you cut it in half, is going to be 5 millimeters, and this is going to be 5 millimeters, and this is all in line. Okay, so we will go ahead and do that. So we're going to grab that line, we're going to grab that line. Those are both going to be equal to each other. They're also collinear. Fantastic. Let's go ahead and dimension that at 5 millimeters. Easy money. Another thing I'm going to do is I'm going to grab all of these points. Remember earlier I talked about how those were equal in length. I'm going to make those both equal and collinear. Now, something got messed up a little bit, which is fine. Just move it around a little bit and get it to work. And you'll still see it looks pretty jacked up. That's okay. We're going to grab these two. Those guys are also going to be equal and collinear. Once again, it looks totally jacked up, but that's okay. Once you start defining stuff, it'll work out really nicely. So let's go ahead and keep defining. So the two primary things that I'm going to be looking at here is the radius of this actual dip itself, as well as the distance or the gap here, which is 5, and this length right here, this guy right here is 5. So let's go ahead and define all of that. Pull that back up. Dimension. This is going to be 25. Easy. This is going to be 5. And keep in mind, we made this collinear and equal earlier. So whatever you change to 1, it's going to change it for both, which is a really nice tool. Fantastic. Okay, we got all that done. Now let's keep going. I'm noticing here. So we have the height is 45 as well as the diameter being 70. Keep in mind, we were only making half the part, so that diameter is going to drop to 35. Okay, so let's do that right now. 35 millimeters. And then 45 millimeters in height. And there you go. We don't, remember you guys, we don't want any blue lines. We want to make sure every single line is black. If it's not, that means it's not fully defined, and therefore it is not a complete part. Okay, let's go to features and let's go to revolved boss base. Revolved boss base is just rotates around a desired axis, and you'll see that right now. So revolving that, you'll see that it takes the sketch profile and rotates it. You can change this up however you want, 15 degrees, 60 degrees. Let's see what that looks like, just curiosity. Okay, so you can get a nice slice of cake right there. But let's go ahead and change it up. Make sure that's 360 where we get the full revolution. Looking good, okay? So that kind of looks a little trippy, but whatever. Let's keep going. Next thing I'm going to be taking care of is this actual center profile right here. Where are you at? Where are you at? Okay, so this kind of center section here, this rectangle, this guy's kind of easy. It might be a little bit hard to tell in the pictures, but it's just a rectangle that's extruded, but there's also kind of this pin thing through it. So it's going to be 25 millimeters in length, 15 millimeters in height, and of course it's weird and it says radius instead of a diameter, but it is what it is. That diameter of that pin is going to be 5. So let's go ahead and do that. Oh, also the actual thickness is 15. So we have 25 by 15 by 15. Easy. With a pin diameter of 5. So I'm going to do a center point rectangle. Just kind of makes things easier. It's, you know, not as pretty, of course, but whatever. Vertical dimension that, 25. And for those of you who are wondering where I get this smart dimension, like if you can't find the smart dimension, it's up here at the top left. But I'm just going to use my wheel because it's faster for me. 15, you'll see that's fully defined, but I'm also going to throw in that pin too. And that has a diameter of 5. And now the thickness in which we are going to extrude from the midplane is going to be 15 millimeters. See that? Easy money. Okay, fantastic. I'm going to go ahead and throw some chamfers on. You see these chamfers called out right here in the side profile. 1 millimeter chamfers, 45 degrees. Easy. So top here, you're going to hit the drop down another fillet. You're going to hit chamfer. And let's go ahead and kiss all of these edges. Boom, boom, boom. And deleted the preview because of the chamfer is too big. We'll go to 1 millimeter. Easy. Okay, fantastic. Now all we got to do is this bottom section. It's got 6 holes in total. It's got a slight chamfer on it. That chamfer being the exact same 1 millimeter chamfer at 45. So you don't actually have to draw out all these 6 holes, but what I'm going to do is I'm going to start a sketch here. I'm going to make this. I'm going to do a construction line. I'm going to define that construction line. And the way I'm going to define that is by looking at this diameter here. So the diameter of this guy is 50. Okay, and that hole is 5 millimeters in diameter, and the depth is also 5 millimeters. So we'll go ahead and do that. So because of that diameter being 50 millimeters, that radius is going to be 25 millimeters. And then this is going to be 5 millimeters. We're going to extrude that to 5 millimeters. And it's not going to be from the midplane, otherwise it won't cut enough. So we're going to go blind. You can change the direction of the blind right here. So we're going to go up into the part. Fantastic. And now we're going to do another chamfer. Chamfer that puppy. Easy. 1 millimeter chamfer at 45 degrees. Now we're going to go ahead and do a circular pattern. We're going to grab these 2 features. The features we're going to grab are the cut extrude as well as the chamfer. And then we're going to pick a direction to revolve around here. That direction could be anything. It could be this guy. It can be an edge if you wanted to. Oh, no, that's another face. It could be an edge. You know what? I like edging. So let's do an edge. And then if you notice, if like right now it's already set up to what I want. So 6 degrees, 360. But sometimes you'll end up with something like this. Maybe it'll be like this. It's like, I don't want that. I want it to be equally spaced, and I want it to go all the way around. So just make sure you select equal spacing, and you could select 6 to get all those holes. I mean, you don't have to do it like this. You can do this, and then what's that? 60 degrees per. And you could do it like that if you wanted to, but I mean, that just makes your life harder. It is called out here, 60 degrees in between each one. So, I mean, do what you want. It's a free country. All right. And that is it for this part. Easy money. Okay. So let's go ahead and hop into the actual assembly itself and finish this guy up. So let's look at the piston test assembly. So construction concentricity bounding guy. That's a mouthful. It's kind of just a fancy word for I'm using a sketch to define some stuff. One sec, my sock is messed up. It's just a fancy way of saying my sketch is doing something cool. That sketch is already in the assembly that you'll get off the bat. The assembly will pretty much all be put together. So let's get after it. Pull that up. I'm going to go ahead and open this guy. Let's see. It's test. So it's going to be piston test assembly. And this is exactly what you'll do on your test. Now, there's something that's not defined here that you shouldn't have to do with your test. But, you know, just if you want to, this guy isn't constrained laterally. So I'm going to use a with mate. With mates are super useful for centering stuff. So if you go under mates, I have mate hotkeyed, but if you don't have it hotkeyed, it's up here. Mate. You can go to advanced. You can go to with, and you're just going to select outer portions. It's really useful. Takes away a lot of the complicated addition and subtraction and division you would have to do normally. Okay, so these are the 3 parts. So you have this part, you have this part, and you have this part. These are all given for the test. Now we just got to assemble this thing. So we're going to go insert components. Okay, you know what? I'm not going to go insert components just because I already have this little folder up. What I'm going to do is I'm actually just going to drag and drop this stuff. And you're going to be using your test parts. You're not going to be using the ones that, obviously these won't come with it. But I don't want to save this stuff because I'm lazy. So I'm just going to drag and drop it. So I need the piston head. And I need the rod. Okay, so we got both of our components. So all we have to do is mate. So one of the cool tricks that you could do, you can either select mate, like a casual at the top, or you can hold control or shift. Maybe you could do it with shift too. And then you let go. So what you do, yeah, you can do it with shift or control. I typically use control, not for any particular reason, but YOLO. So you hold control, you click on this face, and you click on this face, and then you release control. Oh, and now it doesn't do it. Rip. Okay, that time it did it. So, yeah, I click on that, I release it, I do concentric. Fantastic. I grab that, release. Coincident? Cool. So that's the fast way of doing it, but if you're new and you're still having a rough time, let's just go back and just do it normally. Just so that way you don't get confused at all. But I'm going to go mate at the top. You select this pin and this pin. No, pin about the hole. I'm going to select this face and this face. So I'll get this to line up properly. And then before I go through and do these final mates, I'm going to actually rotate this upwards. So that way it doesn't get super confused. And then I'm going to grab this guy and make them concentric. And then finally, I'm going to grab this guy and make these concentric. And that, my friends, is the completed test portion. Just to make sure you guys don't have any blue lines. That stuff is kind of, you need to have fully defined sketches. Otherwise, you will fail. But good luck to you guys. All right. Yeah.